We're continuing our development of conditional probability, and we're looking at what's called the law of total probability. So we'll go through this looking at an example, and then we'll formalize that at the end. In a certain college, 55% of the students are male, 45% are female. Of the male students, 13% say maths is their favourite subject, while the female students say 18% is their favourite. Now we're going to define a few little symbols here. M, male, F, female, P is for the students who prefer maths, i.e. their favourite subject. So we've got to do two things. We've got to determine the probability that a student selected is female and does not prefer maths. And we have to determine the overall percentage of students who prefer mathematics. So a few things are helpful. It's helpful to turn the written information into symbols, mathematical symbology and notation. So let's go through some of the things we've been told here. If we go back to the start of the question, a certain college says 55% are male, so the probability of being a male is 0.55. So we'll write that in. Probability of male is 0.55. Probability of female is 0.45. Okay. And the probability of preferring maths, given that the person is a male, is 13%, because it says of the males, 13% say maths is their favourite subject. So probability of the preference given male, that equals 0.13. Probability of the preference for maths, given that it's a female, is 0.18. So do you see that process? We need to translate the written text into maths type notation for probability. Now we're going to bite off part A first. And for part A, the probability that a student selected as female does not prefer maths, we need to turn that into symbologies too, so we know what we're chasing. So we've got probability the student is female and. So we've got this and thing here, which lends itself to the intersection. So we are chasing the probability of somebody who's female and does not prefer not. There's the negation. So we're going to use the complement. So it's F intersection P apostrophe, because that's one of the symbols we can use to talk about the complement, okay, or the negation, the not. So that's what we're chasing. So at this stage, it's good to look at a strategy which would involve the use of a tree diagram. Okay, so tree diagrams can help us map this out, and I would suggest that as a definite candidate for a good strategy for this sort of task. So really this is very similar to the work you would have done in junior when you were looking at tree diagrams, and we have our first branch where we separate male and female, and then the second stage there where we're separating preference and non-preference, and we have a two-stage tree diagram. So you can see that we can basically follow these all the way through using our multiplication law of conditional probability. Now recall that probability of A given B is the probability of A intersection B over the probability of B. So for this first outcome up here, we would see that's the equivalent to A and that's the equivalent to B, and it's a rearrangement of that, isn't it? So as we've seen in the past, we can rearrange that. The probability of A intersection B equals the probability of A given B times the probability of B. So seeing where these ideas connect, that would be the equivalent to A here, the B there, and the order's the other way around, by the way, but it's commutative because it's multiplication, but you can see that that would be equal to the probability of preferring maths given that it's a male, alright, and that's times by the probability of person being a male. You'll remember we identified all of those probabilities above there. We may repeat that for the others, so the next one would be the probability of somebody who does not have a preference for maths and they are a male, and you could repeat that for all 4 outcomes there. You can see that's done. So we need to look at which one might relate to the task we're doing, and again in part A it's the probability that a student selected is female and does not prefer maths. Now we said that's F intersection P dash, so let's have a look at which one we've got there, and remember they can be written the other way around, F intersection, and it's this one, isn't it? F, remember the intersection, if you drew a Venn diagram, the intersection is a shared zone, so the symbols F and P dash can be switched around with the intersection, because like we've seen previously, that is, no matter which way you look at it, that's a shared intersection. So the answer would be 0.369 or 36.9% if you wanted to write it as a percentage, just like the question was given to you. So the probability that a student selected is female and does not prefer maths is 36.9% or 0.369. The final part now, the overall percentage of students who prefer mathematics. There's maybe a bit more to this than some might first think. So with the preferred mathematics, we need to look for P outcomes. So we have that one and that one there, and we have results calculated for each of those there. So we need to translate again from the real world text to the world of mathematics. So the overall percentage of students who prefer mathematics are these ones and those ones. So we need to add them. It's the union of both. So we need to write that down then. So for part B, it's the union of both of those. So that's the union of P intersection M in union with P intersection F, and we simply add those together. Intersection union, means or, and or is where we add probabilities, whereas with intersection it's and we multiply. So intersection we multiply because it's and union we add because it's or. So we can just write down the amounts from above. We can add them together. I get 0.1525 or about 15.25%. That brings us on to the formal definition of the law of total probability. So you can see it's written there, probability of a certain event A is the probability of A given B times the probability of B plus the probability of A given not B times the probability of not B. And we can see from above that's consistent with what we've just done. Let's do some linking. So this event A up here, remember we're after the total percentage of students who preferred maths, the overall percentage of students who preferred maths. So that would be, if we were to write that using our symbols, that would be P of P. So you can see the intersections we've got by using the multiplication rule, which I've just put up there in light blue. And so for the symbols we've got probability of P, the people who prefer maths, is probability of preferring maths given male times the probability of male, and then union means plus. Okay, we just said that, and added to that would be the probability of the preference for maths given not B, so in other words not male, which is where the female comes from, times by the probability of being a female. Okay, so what I've just done is justify where the rule comes from based on our little investigation with that activity up there.